Hi, I'm Martin Warwick. We're here at the Small Cells World Summit 2014 in London's Docklands, and I'm talking with Sue Rudd from Strategy Analytics. Sue, what factors are driving demand for small cell technology in mobile networks right now?
Well, initially people thought small cells would be needed for capacity for the 3G networks. But ironically, although LTE brings a lot of capacity for 4G, they're deploying small cells with LTE right up front for the dense urban hotspots and for the edge of the macro cells where you need high data throughput. So it's really happening both to help 3G keep extra capacity, especially as they refarm it for LTE, and then also with LTE to make sure everybody gets really high throughput.
What do you think are the key challenges, the problems that are being faced by telcos as they begin to deploy and implement small cell solutions?
Well, I'm sure you've probably heard this from all of them, but they have to change the way they do things, and that's probably one of the hardest things for telcos to do. And they really have to go back to what they actually did in the very early days of cellular, which was to actually negotiate with landlords for rooftop rights or building rights to access this, put the small cells on the buildings, or negotiate with electric utilities to put stuff on the poles. And this requires real practical people to go out and look at places and talk to real people. And so they had to relearn how to put their cell sites on the poles. The other one has been a cost point, and I think one of the exciting things about this particular show is we're seeing the new chips from Qualcomm, and we're seeing several new small cell simple solutions that are dropping the cost of the small cells down to the level where they can really be deployed like popcorn. Because we're talking tens of thousands of these per cellular operator region and even per city. And you're literally going to be paving the ground in some of the big urban areas with small cells.
How does small cells for 4G and beyond fit in with the move towards NFV, Network Functions Virtualization?
In order to manage small cells, you really want to treat with them as a logical group and not have to manage every single cell, but be able to deal with a cluster of cells as a logical entity and say, I will let self-organizing networks, which is a clever technology that can be used at the edge to let the cells power themselves up and down as the capacity needs to increase. And as traffic goes up and down, they actually adjust themselves to follow people down a walkway at an airport. It'd be wonderful if the radio network can actually configure itself. And so then you can deal with that logical group of cells as a virtualized cluster, and that makes it much more manageable. And in fact, small cells really require some level of abstraction in order to be manageable by normal human beings. You just can't deal with these on a cell site by cell site basis.
What role do you see for small cells beyond 4G and into future 5G networks?
I think users view 4G as actual internet speeds to the mobile device. Whether it met the original ITU definition is sort of moot. And 5G was supposed to be something in the 10 times that. Some people even think 100 times that. However, what's interesting, in recent evolution of 5G has made it much more what people are calling the last G, where all the earlier radio protocols get integrated into a common standard. So I can have a 2G, 2.5G, 3G, 4G, all become under one standards umbrella with 5G, and I'll have an architecture that can interwork all of those. So the real relevance for small cells of 5G is I may actually be able to standardize interfaces to legacy protocols with small cells. And in particular, the old ones of 2.5 and 2G are real problems today for interworking. But I'll definitely have 3G, 4G standard parameters within a next generation 5G architecture that probably even has higher speed and over-the-air protocols. So I think 5G will become the unifying. Higher speed will always get more and more efficient, we hope, better codecs, but small cells add capacity, and by adding capacity, the throughput on the macro cells goes up, and the throughput on the small cells goes up because you're managing your load over more of the efficiently reused spectrum. So speeds do go up when you add capacity because users are loading their cell site less.
Is there yet a business case for carrier Wi-Fi? Lots of people say there isn't one.
I've done a lot of work recently looking at all the good reasons why users want Wi-Fi. Users like to switch over to Wi-Fi. In fact, approximately 60% of mobile device usage is over Wi-Fi. Whether or not they do it on a carrier Wi-Fi network will depend on availability. In the US, we're seeing a lot of cellular operators offering a national Wi-Fi roaming footprint. But carrier Wi-Fi is really related to the carrier-owned hotspots. And about 80% of the hotspots are owned by coffee shops and restaurants and hotels and offices in your own home. And so a lot of Wi-Fi use needs to be on networks that are not used to being paid for at the same prices as the carriers like to have. So a lot of the debates about carrier Wi-Fi roaming are limited to the pricing. So to build the business case, the mobile operators really have to start to see Wi-Fi as part of their own spectrum. And we do expect as small cells start to integrate Wi-Fi, and just about every small cell that's being put out there can actually have a Wi-Fi access point as part of it. And the mobile operators will then see Wi-Fi as a seamless part of their HETnet, as they call it, of the spectrum available. And then they'll start to put things like video will be automatically offloaded to the Wi-Fi network so that it doesn't burden the mobile network.
Really fascinating and a different insight. Sue Rudd, thank you.